Hello everyone. The title of this video is Solving an Absolute Value Equation. Now each example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 2.6, called Other Types of Equations. And I'm working under the objective heading Solving an Absolute Value Equation. Alright, so each example in this video is either an example from the reading or one of the try it problems from the reading or one of the exercises from the end of this section that's related to this particular objective. And I would request that whenever I start a new example that you pause the video and try to work it out yourself first before watching me do it, right, and then comparing, because I really feel that you should be practicing these things on your own as well, instead of just watching me do it all the time. Okay? Alright. So all the examples I have written out on paper. And yeah, we're just asked simply to solve the absolute value equation. Now they're called absolute value equations because you will see in each of these equations there's going to be a variable expression, right? An expression with a variable inside a set of absolute value symbols. That's these big straight segments, vertical segments here around. Alright, so we have to recall a few things about absolute value. The absolute value of a real number, you could think of it as the distance from 0 on the real number line. And when we're talking distance, we're talking, something that's non-negative. Right? Distance should be non-negative. Right, so here's, the number line, real number line. Here's the number 0, let's say, and then, let's put up a few numbers. Let's go. I'll just put them some integers here, 1 through 6, and a few more over here. Just throw in some integer notches, -1, -2, -3, -4, -5, and -6, okay, and so on, right? So some simple examples. I mean, the easiest one is 0, right? Here's the number 0. We'll put a little dot there. The absolute value of 0, right, is 0. That is 0 units away from itself. Has a distance of 0 from itself. And this is the only number that has an absolute value of 0. Right? Every other number on the number line is at least some distance away from the center, right? From 0. The absolute value of 1 is, 1 unit, right? The absolute value of 1 is 1. But so is the absolute value of -1. Right? This is also 1 unit away from 0. So the absolute value of 1 is 1, and so is the absolute value of -1. These are both equal to 1. And you're going to see that that's the case, that both, there's a positive number and a negative number that both have the same absolute value. Right? The absolute value of, just to pick one other one, the absolute value of 4 is 4 units, right? The absolute value of 4 is 4. but so is the absolute value of negative 4. Right? Negative 4 is also 4 units away from 0. Okay, so yeah, so for any any other any positive number, right? Every positive number, I'll say this as a note. Every positive number has two numbers with that absolute value, right? One positive and one negative. So every positive number has two numbers, two real numbers with that absolute value. Now another way to say this is the following, is that, the absolute value of, say, x equals k, where k is a positive number, right? If that's the case, then we can say, a little double arrow here, an implication arrow. So if I have the absolute value of something equals k, where k is some constant that's positive, say k is a positive number, then we could say that, well, then x must either be k itself or the negative k, or the opposite of k. Right? And this is what we're going to be doing here. We're going to be using this concept. We're going to be using this concept in the solving of our absolute value equations. We're going to use the fact that if the absolute value of some unknown is a positive number, then that unknown is either that number or its opposite, right? If the absolute value of something was 4, then the number we're taking the absolute value of must either be 4 or negative 4, right? If the absolute value is 1, then that means the number must be 1 or negative 1, right? The only numbers that this doesn't work for negative numbers, right? There's no absolute value that gives you a negative number, right? Absolute value is always 0 or greater. The absolute value is a distance, right? I have the word distance up here. It's never negative, right? Never negative. All right. So that gives me an idea as to how we're going to solve these absolute value equations. So the first step is to isolate the absolute value, that variable expression with the absolute value around it. So right here, I have the absolute value of 1 minus 4x plus 8 equals 13, right? So this absolute value of this variable expression, I'm going to get that alone. I want to get something of this form, an equation that looks like this in the lower right corner here, where I have the absolute value all by itself. Nothing multiplied by it. It's not divided by anything, not added to anything, subtracted to anything, whatever. Absolute value all by itself equal to some non-negative number, right? Either 0 or some positive number, because remember, absolute value can't be negative. So I'm going to subtract 8 here. So we have the absolute value of 1 minus 4x equals, and then 13 minus 8 is 5. Right? And now I apply this, I'll call it, this absolute value property. Apply absolute value property, which is this thing here, right? Now notice we have what we want. I have absolute value alone on one side equal to a non-negative number on the other, right? 5. So if you think back, what numbers have an absolute value of 5? Well, this 1 minus 4x, right, the number we're taking the absolute value of, is either equal to 5, right, because the absolute value of 5 is 5, or this number we're taking the absolute value of, right, 1 minus 4x, it could be negative 5 as well, right, because the absolute, if I replace 1 minus 4x with 5, this would be a true statement, right, absolute value of 5 is 5. If I replaced 1 minus 4x with negative 5, it would also be a true statement, right? The absolute value of negative 5 is also 5. All right, and then we solve these equations, right? Solve these equations separately. And notice there's no absolute value symbol anymore. That's the key. We take an equation that has an absolute value symbol and then rewrite it as, two equations without an absolute value symbol. We undo it, I guess you could say. So this one, 1 minus 4x being positive 5, I would subtract 1, then divide by negative 4, we'd get x equals negative 1, or, and then when 1 minus 4x is replaced with negative 5, we subtract 1, get negative 6, divided by negative 4, x equals positive 3 halves. Right, negative 6 divided by negative 4 would reduce to positive 3 halves, 1.5. And then finally, as with every equation, anytime you are solving an equation, check your solutions. And I always check it, check them back in the original equation, the way it was originally given to you. Now, you can do this in multiple ways. You can do it mentally. Replace x with negative 1 and mentally go through it and see if it's true. Or you can do it by hand, right? I'm going to do that for this first one. Let's check our solutions, right? So the first one I'm testing is negative 1, right? Right, so here we have the absolute value of 1 minus 4 times negative 1, and then after that plus 8 equals 13. Now absolute value is like parentheses. I said it's like parentheses. They're not exactly parentheses, but they're like grouping symbols. You simplify what's inside first. Well, negative 4 times negative 1 is positive 4, then 1 plus 4 is 5. So this is the absolute value of 5, plus 8 equals 13, and then, remember the absolute value is just the distance from 0. Absolute value of 5 is just, 5. The absolute value of a positive number is itself. The absolute value of a negative number, just make it positive, right? It's the opposite. And then we have 5 plus 8 equals 13. So left side's 13, right side's 13. This is true. So I'm going to circle this, right? X equals negative 1, right? Negative 1 is a valid solution to this equation, right? It makes the statement true. Alright, and now let me check the other possible solution we got, 1.5 or 3 halves. So going back up, the original equation with the absolute value of 1 minus, 4 times 3 halves, and then plus 8 equals 13. 4 times 3 halves is 6, right? That'd be 12 halves. So 1 minus 6, this is the absolute value of negative 5 plus 8 equals 13. And the absolute value of negative 5 is positive 5. Right? So it's positive 5 plus 8 equals 13, and it's exactly the same as before, where we have 13 equals 13. Totally true. So this equation has two solutions, negative 1 and positive 3/2 or 1.5. Alright, so you could do it mentally, you can do it by hand, or you could use technology. You can use a calculator if you wish. Now I have and I've shown this to you in other videos if you've been watching. I have a TI-84 emulator on my computer, and I like these TI-84, 83 because of the following feature. It makes checking equations pretty simple. So what I'm going to do is I'm going to enter one of the solutions I'm trying to check, -1, -1, and then I'm going to store this as x. I hit the store button, hit x. So now, every time I hit the letter x, the x button, it's the number -1. Right? And then I go through and I enter the expressions on both sides of my equation that I was given. Now the right side doesn't have any variables, it's just 13, so I don't need to enter that one. I'm just going to enter the sides with variables. Alright, so that left side is the absolute value. Now absolute value on this calculator, I hit the math button, move over to the number menu, and then the first thing is ABS, right? And it comes up there as the absolute value symbols. So the absolute value of, and then inside the absolute value, I have 1 minus 4x. And remember, when I hit x right now, it's representing the number -1. So this is the absolute value of 1 minus 4 times -1. Then get out of there, plus 8, and see, that's the expression on the left side. And this hopefully is 13. And look at that, it is. So -1 is a good solution. And then I'll do the same thing with 3/2, right? Go 3 divided by 2, or 1.5. And then store this, hit the store button, as x. Hit enter, and now, right, now when I hit x, it's 1.5. Right. Then I'll just scroll back up to that expression from the left side of the equation, right? Re-enter it. There's the absolute value of 1 minus 4x plus 8, but this time x represents 1.5, and hopefully I get 13 again. Excellent. So 3/2 also works. 1.5 also is a solution to this equation. Alright, so that's just, and if you don't have a calculator that can store data like that, store a number as a variable, just punch in your numbers in into any old calculator and see that the left expression is the same as the right expression. Great, but always check your solutions. Alright, so once more. We isolate the absolute value, right? Get it like this, absolute value all by itself equal to some, hopefully a non-negative number. If you have the absolute value equal to a negative number, that's never happening, right? We'll probably see that. Actually, we're going to see that coming up next. Then you apply this absolute value property, right? The only numbers that have that absolute value are itself or its opposite, right? And then you solve those separate equations and check those solutions. So yeah, so watch this, right? So example 2. Now, we have the absolute value of 2x minus 3 equals -2. So it's already set up the way I want. Absolute values all by itself. You have nothing multiplied, nothing divided, nothing added, nothing subtracted, and then some number on the other side. But the problem here is that number is negative. Right? Remember, absolute value. The absolute value of something is non-negative. It's either going to be 0 or positive. But then on this side, I have a negative number. Right, so this can never happen. Something on the left, on the left side I have a non-negative number. On the right side I have a negative number. A non-negative number will never be equal to a negative number. So even without doing anything, I say this equation has no solution. Alright, this equation has no solution. I can tell you that without doing anything. I immediately know this because the absolute value can never be negative. Now they might also say that the solution set to this equation is what's called the empty set, right? So just an empty set of braces, right? There's nothing in it. There's no number I can replace the variable with to make it true. Or you might see this like circle with a slash through it. This is called the empty set. Right? But still, you see this, it means the equation has no solution. Now, suppose you didn't see that. Suppose you didn't see this, and you decide to work it the same way I worked example 1. So apply that absolute value property. And you're like, oh, okay. Well, what numbers have an absolute value of negative 2? Well, remember, if it's anything like the other numbers, it would be that number and the opposite. So, you say 2x minus 3 could be equal to negative 2, or 2x minus 3, right, the number inside, the expression inside the symbols, could be the opposite of negative 2, which is positive 2. And then we solve these, and here I would add 3, divide by 2, we get x equals positive 1/2. Or here I would add 3, divide by 2, x equals positive 5/2. But then look at what happens when you check. If I plug in a half, 2 times a half is 1. 1 minus 3 is negative 2, but then we're taking the absolute value. We would get 2 on the left side and negative 2 on the right. That is incorrect. And again, remember what this is called. You find a solution and it doesn't work. This is called an extraneous solution. This other solution that I found also doesn't work. I plug in 5/2. 2 times 5/2 would be 5. Minus 3 would be 2. And the absolute value of 2 is 2. You'd have 2 on the left, negative 2 on the right. That's wrong. So every quote-unquote solution I found is extraneous, right? Is what they call extraneous, unnecessary, doesn't work back in the original. If this is the case, if you go through and you try solving an equation and every solution you found doesn't work back in the original one, that means the equation has no solution. Or you did something wrong. So you double check your work. But most likely, if you did everything, if you did everything right, and still all the solutions you found don't work back in the original, then the equation has no solution. Right? Now, obviously, I would want to avoid all this work. Just recognize that, hey, the left side's an absolute value. That can't be negative. But the right side's negative. So this can't happen. There's nothing I can plug in for x. There's no solution to this equation. I'm hoping you recognize that first before doing all this work. Great. All right, so example 3. Again, I got the absolute value of 4x plus 1. And then after that, minus 3 equals 6. So first I'm going to add 3. All right, we want to isolate the absolute value. All right, get the absolute value all by itself. So the absolute value of 4x plus 1 equals, not positive 9, which is great. All right, I would like a non-negative number on the other side. Because if it was a negative number, then it's just like example 2 and there'd be no solution. But absolute values can be positive, so this might have some solutions. All right, then I apply that absolute value property. What numbers have an absolute value of 9? Well, 9 and negative 9. So this number I'm taking the absolute value of, 4x plus 1, it can either be replaced by 9, right? The absolute value of 9 is 9, or this 4x plus 1, that could be replaced by negative 9, and it would be true as well, right? The absolute value of negative 9 is also 9. And then I'm solving these, right? So this, I'm subtracting 1, dividing by 4, we get x equals 2 is a possible solution. here, subtracting 1, get negative 10 divided by 4. X equals negative 10 fourths, which would reduce to negative 5 halves, or negative 2.5. That's another possible solution. And then check them. Now these I'll just do out loud. All right, again, you can do it by hand, do it with a calculator. I'll just do it mentally and say it out loud. When x is 2, when x is 2, 4 times 2 is 8, 8 plus 1 is 9, the absolute value of 9 is 9, 9 minus 3 is 6, you get 6 equals 6, that would be true. Right? So 2 works. Then negative 5 halves. 4 times negative 5 halves would be negative 20 halves, which would be negative 10, plus 1 would be negative 9. The absolute value of negative 9 is positive 9. 9 minus 3 is 6. That works also. Alright, so this one has two solutions. You can replace x with 2 or, negative 2.5, negative 5 halves. And the equation would be a true statement. Excellent. No extraneous solutions there. Great. And yeah, I'm following the same steps every single time. Isolating the absolute value and hoping that the other side has a non-negative number, applying that absolute value property, what numbers have that absolute value, solving those equations, and then checking. All right, example 4. So once again, I want to isolate this absolute value, get it by itself. So I'm going to add 2. So we have the absolute value of 2x plus 1 equals, negative 3 plus 2 would be negative 1. And, uh-oh, right? That's a negative number on the other side there. I have absolute value being equal to a negative number. Remember, absolute value of any number, any real number, is non-negative. So something that's non-negative equal to something that's negative can't happen. So immediately I can tell you this has no solution. There is nothing you can replace x with to make this a true statement. And I'm done. Alright. Now again, if you don't see that, you could set up the equations and solve them, and you would see that none of them work. Alright, all the solutions you find here would be extraneous. They wouldn't work back in the original equation, I promise you. And also, again, you can say that, if there's no solution, you could say the solution set is the empty set. Right. Same thing. Okay, easy peasy. Alright, now number 5. Now this is already set up the way that I want. The absolute value by itself, right? Nothing multiplied, nothing divided, nothing added, nothing subtracted, just absolute value of some variable expression all by itself, equal to a non-negative number. But this number is 0. Right? It's not positive, but it's not negative either, so it's all right. Now I mentioned before, the only number with an absolute value of 0 is 0. So the only number I could replace x plus 5 with is 0. Right? There aren't two equations here. Now you could do 2, 0 and the opposite of 0, but the opposite of 0 is 0, right? So you'd be writing the same equation twice. That'd be silly. So yeah, so this x plus 5, the number, we're taking the absolute value of, the only number that'll work is 0, right? The absolute value of 0, 0. And then solve this, right? X equals negative 5, subtracting 5, right? And of course, check, if I replace x with negative 5, you have the absolute value of 0 equals 0. You have 0 equals 0, which is true. So this works. The only solution to this equation is negative 5. Great. And I have just one more of these, right? They're all the same. Doing the same steps every time. Alright, now here, again, I want to isolate the absolute value. I want to get just the absolute value of the variable expression alone. So this, there is a number being multiplied by the absolute value. I don't want that there. So I'm going to divide both sides by -1, right? It's times -1 technically. Divide both sides by -1, and that'll isolate the absolute value. So the absolute value of 2x plus 1 equals, and then -3, divided by -1 would be +3. Great. It's not a negative number on the other side. So I've isolated the absolute value. It's not a negative number on the other side. Excellent. That means this probably does have some solutions, right? Again, if it had a negative number over here, there'd be no solution. All right, so now I can apply that absolute value property. What can I replace 2x plus 1 with? 2x plus 1 can either be 3, right? The absolute value of 3 is 3, or this 2x plus 1, right, inside the absolute value symbols, this could be -3 as well, right? The absolute value of -3 is also 3. So I'm solving these two equations. Now the first equation, subtract 1, divide by 2, you get x equals 1 as a possible solution. And here, subtract 1, you get -4, divided by 2, x equals -2 as a possible solution. And then once again, I'm going to check these. Now again, you can use a calculator, do it by hand. I'm going to check them out loud. All right, I'm going to just check them out loud. When x equals 1, 2 times 1 is 2, plus 1 is 3. The absolute value of 3 is 3, but then you got this minus sign here. -1 times 3. So the left side is -3, the right side is -3. Right, you get -3 equals -3. That is a true statement. So x equals 1 works. Then -2. 2 times -2 is -4. -4 plus 1 is -3. The absolute value of -3 is +3, but then you got the times -1. So again, you have -3 equals -3. This also works. All right, and you may have caught the pattern here. If you have the absolute value of a linear expression like we've seen in all these, first degree polynomial, equal to a positive number, there were two solutions. When it was equal to 0, there was only one solution. And when it was equal to a negative number, there were no solutions. Great. And I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to solve an absolute value equation on your own. And thank you very much for watching.